All right, this is Math 0310. It's March 20th. Spring starts tomorrow. A couple of announcements before we get started. WebAssign homework is due today. I did give you a couple of extra days on 9.5, 9.6, and 9.7, which was originally due on Sunday, and I gave you through today to finish that up. And then 9.8 and the section on complex numbers will be due on March 25th. So make sure that you keep up with your WebAssign homework. Most of you are doing relatively good at keeping up with that during the semester. Exam 2. The review has been on my Google site now for probably close to 2 weeks. So make sure that you work on that review. The review is a very lengthy review, lots of homework or lots of practice problems on that review. It's a very good review for this test. So spend some time with that, definitely, between now and the time you take the test. The window for the test is March 22nd through the 27th. Make sure that you allow yourself about 2.5 hours time limit to take that test. It shouldn't take you 2.5 hours. Most people finished the first exam in 1.5 hours or even less than 1.5 hours. It should not take you 2.5 hours, but you want to allow yourself enough time so that if you have struggle with a problem, that you have time to do that. Remember that a calculator is allowed, but no graphing calculator on the test. Office hours. Today I will be online from 11 to noon, and then again on Sunday from 8:30 to 9:30. I will be on campus. And remember, when I say on campus, we're talking about the North Harris campus. And my office is in Winship 115K. And I will be on campus Wednesday from 4 to 6. Thursday, note that a little bit of a time difference. I've been saying 9 to 11, but it's going to be 9:30 to 11:30 on Thursday. So make sure, and it says PM there. I'm not really sure why it says PM. I just noticed that. It's 9:30 to 11:30 a.m. That makes more sense. All right, so not Thursday's hours, 9:30 to 11:30 a.m. Also, kind of wanted to give you guys all a heads up that I will not have access to email this Friday or Saturday. So if you do email me on Friday or Saturday, it won't be until Sunday that you get an answer, just to make sure that you were aware of that. Also, one other thing to mention, remember, no lecture. No lecture on Thursday or next Tuesday. Right? No lecture Thursday because I'll be on campus. No lecture next Tuesday because it's still in the testing window. All right, so the next lecture in this class is going to be March the 29th. So after today, the next lecture will be March the 29th. All right, so what I want to do today is, we're continuing on in the material. We've been talking about solving quadratic equations, and that's kind of where we are right now. We've been talking about methods for solving quadratic equations, and so far with methods, what we've talked about is we've talked about factoring to solve a quadratic equation. And remember, factoring involves the idea that if you have a times b equals 0, that either a has to be 0 or b has to be 0, right? You just set each factor equal to 0. We've talked about the square root method. And the square root method, remember, involves the equation must be in the form something squared equals a constant. You have to have the equation looking in that form. So you got the square root method. So both factoring and square root methods for solving quadratics, I call those kind of special methods for solving quadratics because they don't always work. Right? Factoring, the expression's got to be factorable. And with the square root method, the equation's got to be in the form something squared equals a constant. So those methods are kind of special methods because they don't always work. But when they do work, they're by far and away the most efficient methods for solving a quadratic. So the factoring method, remember, if you have something, like x squared minus, minus 4x minus 21 equals 0, got to have the equation equal to 0. But once you do, remember, if you can factor the equation or the expression, then it's a pretty easy equation to solve. Like x squared minus 4x minus 21 factors x minus 7 times x plus 3. And then you just set each factor equal to 0 and solve. So works out pretty efficiently. Square root method. If the equation is in the form something squared equals a constant, it's a pretty efficient method for solving an equation. Just take the square root of both sides of the equation. You get 2x minus 1 equals, don't forget it's got to be plus or minus the square root of 20. And so don't forget the plus or minus there. And then you simplify the radical. Don't leave the square root of 20. Remember, the square root of 20 breaks up as the square root of 4 and the square root of 5. So that'd be plus or minus 2 times the square root of 5. And then you solve for x. So once again, this is not too bad of a method for solving a quadratic. Usually works pretty efficiently when it works, right? When the equation is in the form something squared equals a constant. Now the next method for solving a quadratic that we've talked about is completing the square. And with completing the square, it is a way of taking any quadratic and forcing it to be solvable by the square root method. And the square root method, or the completing the square, is a little bit more involved, right? There's more steps involved, excuse me, to this type of equation. So if we have 2x squared minus 8x plus 5 equals 0. We'll look at that equation. 2x squared minus 8x plus 5 equals 0. It's not factorable. Certainly, you can't use the square root method like it is. So we're going to complete the square to solve this equation. And so don't forget that the first thing we did is we moved the constant to the other side of the equation. And then whatever the, and by the way, I'm going to change this, instead of plus 5 there, I'm going to put a minus 5 in there. And then that makes this a plus 5 right there. That'll be better. All right, and so then you go through and you divide by the leading coefficient if there is something other than a 1 there. So I have to divide everything by a 2. So you get x squared minus 4x equals 5 halves. And then don't forget that this next step is kind of the critical step for solving by completing the square. You take half the middle coefficient, and then you square it. Remember, it's a two-step process. You take half the middle coefficient and you square it. And that is the constant that you add to both sides of the equation. So in this case, I add 4 to both sides of the equation. Like that. And when you do these steps, go through these steps here, you've completed the square, and this trinomial on the left side, recall, always factors as the square of a binomial. And it factors, in this case, is x minus 2 squared. And the other side of the equation, I've got to use I've got to add those fractions together. So that's 5 halves plus 8 halves, right? Just change 4 to 8 halves. So you get x minus 2 squared equals 13 halves. And see, now that equation looks like the one I worked a minute ago. It's something squared equals a constant. So I take the square root of both sides. I get plus or minus the square root of 13 halves. You probably would rationalize that, multiply by the square root of 2 over the square root of 2. And that would give me x equals, and I'll add the 2 here because I'm running out of room. So you have x equals 2 plus or minus the square root of 26 over 2. Don't forget that the square root of 2 times the square root of 2 in the denominator there is equal to 2. Right? And so then you've solved the equation. It can be a messy method to use to solve by completing the square. All right, so those are our 3 methods we've discussed so far. Factoring, the square root method, and completing the square. And so today what we're going to do is look at the 4th method for solving quadratic equations, and that is by using the quadratic formula. And so the first thing we're going to do is we're going to go ahead and derive the quadratic formula here. And so to derive the quadratic formula, what we're really doing here is we're going to solve, and this sounds kind of weird to say this, but we're going to literally solve every quadratic equation that exists at one time. We're going to solve all of them at the same time. And to solve all of them at the same time, what you're doing here is you're taking this equation, ax squared plus bx plus c equals 0, and I'm going to solve using completing the square here. And notice that that equation, ax squared plus bx plus c equals 0, that represents every quadratic equation that you can write, right? You just pick a, b, and c value, and you get a particular quadratic. So every quadratic can be written in this form. This represents every quadratic equation. So this represents every quadratic equation. And so what we are doing here is we are solving, literally, we are solving every quadratic equation at one time. Right? We're going to solve every quadratic at the same time. And what we're going to do by going through this is we're going to actually create a formula whereby we're we can solve a any quadratic equation using this formula. All right, so this is what we're going to do. We're going to, and I will say that this is going to be messy. But what we're going to do is follow the exact same steps that I did a second ago at the bottom of the screen here, where we completed the square. We're really going to be doing exactly the same steps. It's just going to look kind of messy because you've got these coefficients, a, b, and c, are not constants like you're used to. I mean, we're using letters here in their place. But remember, the first step is to move the constant to the other side of the equation. So I moved the c to the other side. All right? And then we go through and we literally divide every term on both sides of this equation by the leading coefficient. Since there's not just a 1 in front, we divide everything by a. Now, unfortunately, that kind of leaves a messy expression. Now, the a's cancel in the first term, which is what's supposed to happen. That's why you did that. In the second term, the coefficient of the x is b over a. And then on the other side of the equation, this is just a constant, and it's negative c over a. All right, and so now we're going to fill in the blank with the constant that we've been picking for completing the square. And remember how you do this is you take half of the middle coefficient. So the middle coefficient here is b over a. And so you take half of it. You literally multiply it by 1/2, and you get b over 2a. But remember, it's a two-step process. It's not just multiply the middle coefficient by 1/2, but it's also square what your result is. So I'm squaring b over 2a, and I get b squared over 4a squared. Believe it or not, that is the constant that you were going to add to both sides of this equation. So I'm going to literally add, it's a yucky constant, isn't it? So you're going to add b squared over 4a squared right here. And I'm going to add it to the other side of the equation also, but when I add it over here, I'm just going to put it at the beginning rather than at the end. And I'll put the negative c over a at the very end. It just looks better that way. All right, so I added that constant of b squared over 4a squared to both sides of the equation. Now, on the left side, this trinomial, believe it or not, factors. And remember the pattern, the way it factors, it's always the square root of the first term, the sine of the second term, and then the square root of the third term. The third term is the yucky one, but the square root of b squared over 4a squared, that's actually a nice square root. It's just b over 2a. Just taking the square root of each little factor there. On the right side of the equation, I have got to go ahead and add those two fractions together, so I need a common denominator, which is 4a squared. And so what you have to do is you have to multiply the second fraction by 4a over 4a. And this will give you b squared over 4a squared minus 4ac over 4a squared. See, what I'm trying to do is trying to get the denominators to be the same, so I could go ahead and subtract them. And now they are the same. So on the left side, I'm just going to leave this as x plus b over 2a squared. On the right side, I go ahead and combine these fractions. And so you get b squared minus 4ac over 4a squared. All right, now the b squared minus 4ac, I can't do anything with that. Right, so I just leave it. They're not like terms. Now I take the square root of both sides of the equation. So the square root on the left side is just x plus b over 2a. And on the right side, you've got plus or minus, and you've got the square root of this big ugly fraction right here. Now the numerator of that fraction is got an addition in it, and so I cannot do anything with that square root. So I've got plus or minus the square root of b squared minus 4ac in the numerator. The denominator, though, does have a perfect square root. Right? The square root of 4a squared is 2a. And that's all multiplication, so I can leave it like that. And then I finally solve for x. I subtract that b over 2a from both sides of the equation. I'm going to kind of put it over here so I have room. So I subtract b over 2a, and I'm going to put that at the beginning, plus or minus the square root of b squared minus 4ac all over 2a. And then those two fractions that have the same denominator. And so I can go ahead and add those together and combine those. And so I get negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula right there. This is a formula that allows you to solve literally any quadratic equation. All you have to do to use this formula is you have to be able to identify the a, b, and c values. And remember, the a, b, and c values come from this standard form of that quadratic right there. Right? And so if we have the equation in the form ax squared plus bx plus c equals 0, and we can identify a, b, and c, then we literally can just substitute them into that formula, and we can actually calculate the solutions to that equation, right? And this is something you can use for every quadratic equation. Right? All quadratic equations are solvable using the quadratic formula. It doesn't matter whether it's factorable. None of that matters. It just matters that you can identify the a, b, and c values. So the equation has to be in standard form to be able to solve this. All right, so let's write that down again on this page. So we have this equation, right? Any equation in the form ax squared plus bx plus c equals 0 has solutions that look like this. X equals negative b. And when I write negative b right there, I really, the way to look at that is that it's the opposite of b. So whatever the b value is, you write down the opposite of b in this spot. And then you have plus or minus, that's addition and subtraction. And then you're adding or subtracting this radical. And the radical underneath is b squared minus 4ac. And then that's all divided by 2 times the a value. All right, so we're going to go ahead and solve a few quadratic equations and then look at a word problem there, or two maybe, and then we're going to be done with our lecture for the day. So in your textbook, we're in section 10.3 of your textbook, and this is page 1177. And I'm looking at problem number 100 on that page. So you have this equation, 4n squared minus 9n plus 5 equals 0. Now I've got the equation at the top written in terms of the variable x. It doesn't matter what the variable is. Everything's exactly the same. Instead of x equals negative b plus or minus blah, 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 you'd have n equals all that. Nothing else is different. So make sure the equation's in standard form, and if it's in standard form, then go ahead and identify the a, b, and c value. So this is in standard form. So the a value is 4, the b value is negative 9, and c is 5. And so we would go ahead and substitute those into our formula. So you have x equals the opposite of b. Remember what I told you is that negative b that's in the numerator, think of that as the opposite of b. Let me write that down. The opposite of b. And that's what that term is. Think of it as the opposite of b. So b in our problem is negative 9, so the opposite of b is positive 9. And then you write down the addition and the subtraction, plus or minus. And then the square root, use parentheses on the inside here. Always use parentheses here. So this is negative 9 squared, that's b squared, minus 4 times a times c. And this would all be divided by 2 times a, 2 times 4. Okay, so you've got the formula written out. These are the solutions to the equation. All you need to do now is do the arithmetic and simplify this expression. So you have 9 plus or minus the square root. Negative 9 squared is 81. And then this would be minus 4 times 4 times 5. 4 times 4 times 5 is actually, let's see, 4 times 4 is 16, times 5 is 80. So you have 81 minus 80, and then this is all over 8. So you get 9 plus or minus the square root of 1 over 8. By the way, the square root of 81 minus 80, you cannot take the square root of each of those separately, so because it's a subtraction problem. So you can't take the square root of 81 and then the square root of 80, right? It's not equal to that. So don't try to do the arithmetic that way. You have to simplify underneath the radical and then take the square root of what you've got left. Now the square root of 1, don't get your calculator out and try to evaluate the square root of 1. Come on, you know that the square root of 1 is equal to 1. And so if the radical simplifies, you go ahead and do that. In other words, if you can evaluate the radical, do that. So you have 9 plus or minus 1 divided by 8. Do not leave it like that. Right? Write this out as 9 plus 1 over 8 and 9 minus 1 over 8. By the way, because the square root of 1 was 1, because we actually got a perfect square under the radical and we could actually get rid of the radical, like, you know, the radical has disappeared from this problem, what that means about the original expression, the original equation, was that it was factorable. We could have actually solved this equation by factoring, which I'm going to do in a minute, and I'll show you that factoring is more efficient than the quadratic formula, certainly. So what do we get here? We get 10 over 8 which simplifies as 5/4. And then we have 8 over 8, which simplifies as 1. And so those are the solutions to this equation, 5/4 and 1. Now, you could have solved this by factoring. And like I said, I know that this is solvable by factoring because all the radicals dropped out of the equation. If they all drop out, then it's for sure factorable. And so you've got 4n squared minus 9n plus 5 equals 0. And notice that I could have solved this by factoring. I would have had 4n minus 5 times n minus 1 equals 0, like that. And then set each factor equal to 0. And you would have, sure enough, gotten the exact same thing, 5/4 and 1. Notice that factoring is definitely more efficient than the quadratic formula. But, if you don't see how the expression factors, or if it's not factorable at all, then the quadratic formula is certainly the way to go on the problem. Okay, so that's our first example. Please stop me if you've got a question as we're going through this, okay? So problem number 114 is next that I want to look at. You have 3w times w minus 2 minus 8 equals 0. Okay, so this equation is not in ax squared plus bx plus c equals 0 form. It has to be in that form in order for you to be able to solve using the quadratic formula, because you need to know what a, b, and c are. So we multiply through by 3w here, get rid of the grouping symbol. So you have 3w squared minus 6w minus 8 equals 0. Now it's in, now this is in ax squared plus bx plus c equals 0 form, right? You need the equation in that form before you can solve using the quadratic formula. So in our problem, this would be a equals 3, b equals -6, and c equals -8. And off to the side here, let's write down our quadratic formula so we have it sitting in front of us. Right, x is the opposite of b plus or minus the square root of b squared minus 4ac over 2a. If you're not used to using the quadratic formula, I would literally write it down. Every problem you use the formula on, I'd write it down. And sure enough, somewhere along the line, you'll find that you can stop writing it down because you know the formula. Okay, so in our problem, the variable is w, so you have w equals the opposite of b, should be 6, plus or minus the square root of b squared, would be -6 squared, minus 4 times a times c, and notice c is -8. All divided by 2 times a, which should be 2 times 3. Okay, so you've got everything put into the formula, and now it's an arithmetic problem. So you have w is equal to 6 plus or minus the square root of 36. Now notice that in the next part here, you have -4 times 3 is -12, but then that's times -8. You end up with 2 negatives in there, so this ends up being an addition problem. When it's 4 times 3 times 8, 4 times 3 is 12, times 8 is 96. So you have 36 plus 96 under the radical, all divided by 6. And so this gives you w equals 6 plus or minus the square root of 132, right? 36 plus 96 divided by 6, like so. You cannot divide out the 6's. Don't try to do that. because the 6 is not a factor of both terms of the numerator, you can't divide that out. So do not divide the 6's. All right, the 6 in the numerator is a term. Right? Don't try to divide that out at this point. Instead, the only thing you can do here is you can simplify the radical. You always simplify radicals. Now, the square root of 132 is, that's not a perfect square, so we have to try to find a factor of 132 that is a perfect square. So, we need to divide that up. Let's say we know for sure that 4 divides into 132. Let's see if we can do any better than that. 132 is 4 times 33. And so that's as good as we're going to be able to do. And so we break this up as the square root of 4 times the square root of 33 over 6. And so that would be 2 times the square root of 33 in that second term, all divided by 6. Now, do not try to add the 2 and the 6 together also, because you're violating order of operations. But now what you can do here, because the 2 is now common to all 3 terms, we have talked about this before when we were talking about radicals. Now this is something you can do. You can divide out the 2 because it's common to all 3 terms. So must be common to all terms, right, in order for you to be able to divide it out. And because there is a 2 common to all terms, I can divide the 2 out. And so I get W equals 3 plus or minus, technically 1 times the square root of 33 over 3. And then there's nothing I can do with it from there. The 3's don't divide out, remember, because the 3 in the numerator is a term. And so these are your solutions. And you literally write it this way. By the way, while we're talking about this, in WebAssign, very frequently, they will ask you to enter the solutions as, they'll say something like, enter it as a comma-separated list. So if they ask that, then what they're asking you to do is write one solution out, 3 minus the square root of 33 over 3, comma, and then write the next solution out, 3 plus the square root of 33 over 3. That's common for WebAssign to ask for that form. So I wanted to kind of give you a heads up about that. All right. So let's see. Make sure that there's no questions here. No one's shouting at me at all. So I guess we're okay at this point. Next problem I want to look at is number 128. We have a problem with a fraction in it, or actually several fractions. This is also not equal to 0. So a couple things here. If you're going to use the quadratic formula to solve a quadratic, you sure as heck don't want fractions as the coefficients, because that's just going to make your life miserable later on when you're looking at the quadratic formula. So before I do anything on a problem like this, I would get rid of all fractions. Right? You don't want to worry about fraction arithmetic later on here in this kind of problem. So in this equation, what I'm going to do is I'm going to multiply both sides by the least common denominator, which in this case is 9. Right? And remember, you're multiplying both sides by 9 over 1. So on the left side of the equation, 9 times 1 over 9 is 1, and so you're just left with c squared. And then 9 times 2/3 is 18/3, or 6. So this is 6c right here, equals 27. Get rid of the fractions before you do anything. And then remember, it must be set equal to 0. And the equation is not set equal to 0, then you need to make sure that it is equal to 0. So I subtract 27 like that. You get 6c squared plus 6c minus 27 equals 0. And now I can use the quadratic formula, right? Quadratic formula, I write it down off to the side. So in our problem, the variable is c. So you have c is equal to the opposite of b. Oh, and I didn't write the a, b, and c down. So a is 1 in this case because the coefficient of the c squared is a 1. The b is a 6, and the c is negative 27. So the quadratic formula here would be c equals the opposite of b, which would be negative 6, plus or minus the square root of b squared. So that would be 6 squared minus 4 times a times c, which is negative 27. This would be all divided by 2 times 1, 2 times a. Okay, so you've got everything substituted into the formula. And so now you have c equals negative 6 plus or minus the square root of 36. Once again, be careful here. This is a negative and a negative. So you're going to end up with an addition problem here because you have two negatives. 4 times 1 is 4, times 27 is 108. And this would all be divided by 2. Do not be tempted to divide the 6 and the 2 out. Remember, don't do that because the 2 is not common to all three terms, or at least you don't know that it is. So, all right, so let's simplify this radical. Well, this is the square root of 144 over 2. Square root of 144, that's a perfect square. So you end up with negative 6 plus or minus 12 over 2. And so that meant, remember, that the original equation was factorable. When you get a perfect square under the radical like that, it means the original equation is a factorable expression. All right, so you get two solutions here. You get negative 6 plus 12 over 2, and you get negative 6 minus 12 over 2. So that gives you 6 over 2 here, or 3, and negative 18 over 2, which is negative 9. And so our solution set here is going to be 3 and negative 9. And you could have definitely factored this expression and gotten to that much faster. There's no question about that. All right, so hopefully we are doing fine here. So the next problem I want to look at, let's go ahead and look at, this is number 125 on that section, and this is going to probably be the last of the equations I'm going to look at, and then I'm going to look at a word problem or two to finish up the day. So number 125, you have 2a squared plus 12a plus 5 equals 0. So this equation, and actually, you know what I'm going to do is I'm going to go ahead and change this problem up because there's something I want to do in particular here. So I'm going to say 2a squared plus 5a plus 12 like that. I'm going to actually switch the 5 and the 12 around. So this is the equation. This is no longer number 125, so let me erase that too. So this is just an example. Okay. So now it's like I want the problem. So you have a to be 2, b to be 5, and c is 12. And remember that the formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right. So I'm going to go ahead and substitute into the formula. The variable in my problem here is a equals. So I have a equals the opposite of b, so that'd be negative 5, plus or minus the square root of b squared would be 5 squared minus 4 times a times c, all divided by 2 times a. Okay, so I've got everything substituted into the formula. And so you have negative 5 plus or minus the square root of 25 minus 4 times 2 is 8 times 12 is 96. So 25 minus 96, all divided by 4. And so you have a is equal to negative 5 plus or minus the square root of negative 71 over 4. Now, on WebAssign, if WebAssign asks for real solutions, then notice that in our problem, I have the square root of a negative number. Those are not real numbers here. Those are imaginary numbers. And so you would say no solution in this case. But on an exam, like on exam 3, and on the final exam, I'm going to ask you, I will ask for all solutions, real or imaginary, not just real solutions. And so I would not want you to write no solution here. I'd want you to go ahead and write out these solutions and simplify this as much as you can. So the square root of negative 71, you're going to rewrite that as the square root of negative 1 times the square root of 71. And so don't forget that the square root of negative 1 is I. Let's see, if I times the square root of 71 there in the numerator, and that's all over 4. So I'd want you to write out those imaginary solutions here in this type of equation. In WebAssign, there's liable to be problems where they ask you only for the real solutions, in which case, if they do ask that, then you're just going to simply write no solution down at all for the problem, okay? All right, and so what we're going to do now is we are going to finish the problem, or finish quadratic equations, I should say, by looking at a couple of word problems. And then that will finish up the word problems, and then we will be done with what we're going to do for this section, okay? So this is section 10.4 of your book, where you're looking at some word problems here. So in section 10.4, problem number 144 says, this is the way the problem is worded. I'm going to write out the highlights of the problem here. It says the product, and so when you see that word, that's a key word in a stated problem, because product means multiply. The product of two consecutive even numbers. So consecutive even is important. Consecutive even means that you have two even numbers that are literally come right after each other. So you're talking about even numbers being 2, 4, 6, 8, 10, and so on, right? So consecutive even would be something like 4 and 6, or 6 and 8, or 8 and 10. So product means multiply. Make sure that you know that. Consecutive even, in general then, the first one would be x, and the second one would be x plus 2, because it would always be 2 more. When you see consecutive even, that's how you'd write the two numbers out. Okay, so the product of two consecutive even numbers is, okay, the word is would translate as equals. Is 360. And it says find the numbers. So what are we going to do? It says the product means multiplies, product of two consecutive even integers. So we multiply x and x plus 2 down, and that should equal 360. Right? And there is our equation, right? This is a quadratic equation to solve this problem. All right, so if we go ahead and it's not in standard form, right? So if we're going to solve this, we'd multiply this out. So you have x squared plus 2x equals 360. And then you'd subtract 360. And then the idea here is you want to use the most efficient method you can to solve this equation. So now 360 is kind of big, but you kind of hope that this is a factorable expression. And if it's factorable, then you could solve the problem pretty quickly. And this is factorable. I know it's big, the numbers are big, but I'm going to go ahead and tell you how it factors. It's going to be x plus 20 times x minus 18. 20 times 18 is 360. 20 times negative 18 is negative 360. And remember, the middle two terms give you a positive 20x, and the outside two give you a negative 18x, and those add to give 2x. So this is the most efficient method. You could have used the quadratic formula here to solve this, but notice with that 360 in there, you do get numbers that are pretty big when you use the formula. And so, it's nice to be able to avoid that when you can. So you set each factor equal to 0, and you get x equals negative 20 and x equals 18. Now you got to be careful here, because the directions say to find the two numbers. Don't think that you're finished with the problem yet. The two numbers are the first number and the second number. But what does x represent? Because that's what we've solved for here in this problem. But x represents the first number, right? And so these are examples, and there's two examples of the first number here that make this statement true. So the second number, or the second integer here, is going to be x plus 2. It's 2 more than that. And so if x is negative 20, then negative 20 plus 2 is negative 18. And if x is 18, then x plus 2, 18 plus 2 is 20. And so there are two answers to this problem. There are two examples of consecutive even integers, consecutive even numbers that multiply to give 360. And the two numbers, the two examples, or the two answers to the question are negative 20 and negative 18, and 18 and 20. All right, so sometimes you get word problems where there's actually two answers. That's not rare for that to happen. Usually happens with number problems like this, not with actual application problems. Okay, so let's look at problem number 156. And I kind of think that number 156 is going to be our last problem of the day, and that will finish up with what we're going to do today. And I'll answer any questions that anybody still has for those of you who are with me live today. So number 156, you've got a rectangular lawn. So it's a rectangle. Area is 140 square yards. So yards squared, 140 square yards. The width, and this is probably the critical sentence here, is the width is 6 less than twice the length. Right? The width is 6 less than twice the length. What are the length or find the length and the width, right? That's what you're asked to do here at the end. Find the length and the width. All right, so the area is 140 square yards, and you know that area is equal to length times width, right? And so what we need to do is write down the length and the width here. We know that the width is, right, that's an equal sign, 6 less. 6 less means you take 6 away from something. It doesn't mean you take it away from 6. It means you take 6 away from it. And twice the length right here, right? And so if you let, so that's what the width is. So if you let the length be x in our problem, and let me write it out this way. So the length is equal to x, then the width, which is the sentence in the problem, is, that would be equals, the width is 6 less, you take 6 away from something, twice the length. So that'd be 2 times x. Right, and that would be the width here. And then we use the idea that length times width is equal to area. And so you have x times 2x minus 6 equals 140. So this is a problem, you've got your quadratic equation here. So now you want to put this in standard form. So you multiply through by x. I do want you to note that there's a common factor of 2 in every term here. So in a quadratic equation, when you see that there's a common factor of in every term, divide every term by that number to get rid of it. That makes sense to do. So you get x squared minus 3x equals 70. Just makes the number smaller. And then you subtract 70, and now the equation is in standard form. And this equation also is factorable. This expression is factorable. Factors x minus 10 times x plus, not plus 3, plus 7. That's better. So x minus 10 times x plus 7 equals 0. So you have x minus 10 equals 0, or x equals 10. And x plus 7 equals 0, or x equals negative 7. This represents length right here. And the length cannot be negative, so you throw out the negative answer. And so the length is going to be 10 right in our problem. This is going to be 10. And then the width would be 2 times 10 minus 6, or 14. And the units here were yards. So that's going to be yards there, and that's going to be yards there. So it's 10 yards by 14 yards. Or 30 feet by 42 feet. Right, and that would be the solution to our problem there. All right, so that finishes up what we're going to do pretty much with solving quadratic equations. There's still maybe a little tiny bit that we might end up picking up with applications. But what we're going to do when we come back on March 29th, or March the 29th, that's right. So when we come back, we will be going on to graphing and looking at equations in 2 variables. So on March 29th, there's a big change in the class. Because what we're going to do is we're going to move on to graphing in the plane. Critical for college algebra. College algebra is a graphing course. My students in college algebra are graphing constantly, all sorts of different kinds of graphs. So we're going to be talking about graphing in a plane. We're going to be talking about functions. And that's what we're going to spend much of the rest of the semester dealing with in this class. So it's going to be a really big change for us when we come back. Some of you will probably like the change. Some of you probably will not like the change. Some of you I know don't like graphing. Some of you like graphing a lot more than factoring and solving equations, quadratic equations, things like that. So, what we're doing is preparing for college algebra. It's a big topic for college algebra. All right. So the last thing I'm going to tell you here is work on the exam to review. Work on WebAssign. The homework that you have on WebAssign is a review for the test. So the WebAssign homework that's due today and on Sunday is a good review for exam 2. So that will help you also. Work on WebAssign. That's the other thing I'm going to say here. Don't hesitate to come by my office hours, online office hours, either today from 11 to 12 or Sunday. Remember, I'm going to be online, or I'm going to be on campus on Wednesday and Thursday this week from 4 to 6 on Wednesday, from 9:30 to 11:30 in the morning on Thursday. So please don't hesitate to try to come by for help. I'll be happy to help you out. Send me an email. Remember, I won't have email on Friday or Saturday, but outside of that, I'll certainly be answering emails also. All right, so please try to get some help. Go to a math lab somewhere, get some help there if you need it. I'll be happy to help you out. You know I will do that. So anybody who's with me right now have any questions?
No questions.
All right, then I'm not hearing anything else from anybody else. So